In the last section of chapter 4, we're going to talk about quadratic inequalities. And this is not a new topic because we have already worked with nonlinear inequalities. So this should be a quick reminder for you. In order to solve a quadratic inequality, so that would be like ax squared plus bx plus c is like greater than something, some number. You're going to start by replacing the inequality with an equal sign. Then we will solve the equation and make intervals on a number line so we can test values. So we'll create a number line. And then whatever we got for our solutions, our two solutions on that quadratic equation, because remember we started by replacing it with an equal sign, we're going to make divisions on our number line. So one thing to remember is that if we had a less than or greater than, we're going to use an open circle. If we had a less than or equal to, or greater than or equal to, we're going to use a closed circle. Open circles can also be for a not equal to sign. So like if you had some, if you were restricting the domain in the denominator, if it was a not equal to, you would use an open circle. I usually draw my division lines either dashed or solid, depending on if it was open or closed. And then I will usually create intervals here with either open or closed parentheses, being parentheses or brackets, depending on which symbol. So I'll use a parenthesis here for my interval notation, but I would use a bracket here for my interval notation. That's just so when I'm done, I have the answer that I was trying to find. Then we're going to test a value in each of the intervals. So when you do that, it's very important to make sure that the number you're testing actually is in that interval. That's one of the more common mistakes that I will see. So you're going to substitute a value from each interval. And I will usually recommend that you sub that into the original inequality. That way, if there were any mistakes made along the way, you're not like compounding those mistakes by continuing to use something that wasn't correct. The other thing you got to be careful about is you cannot substitute the border values. So I'm going to say do not use the border numbers. So don't use these two numbers that you solved for when you are doing your testing. So when you do that testing, you're either going to get an inequality that is true or an inequality that is false. If you get something that is true, so if you end up with a true inequality, then what you'll do is you're going to shade in that part of the number line, and that will be your graphical answer. And then your interval notation answer would be the interval that you had listed there. If you get a false inequality, then that means that that section was not a valid part of the solution, so I usually just X through it. Speaking of your answers, the answer may be requested in three manners. On a number line, so that would be this shaded part of the number line, in interval notation, which would be this part, or in set builder notation, which would be the curly bracket, X bar, and then the inequality that you ended up with here. So I will show you all three of those answers, those types of answers, when we solve this problem right here. So this problem doesn't give you a direct inequality to start with, but it does ask you to find the domain of a radical. And remember that when we need to find the domain for an even index radical, the way that we do that is by setting the radicand, which is the stuff inside the radical, greater than or equal to 0. So to find the domain of this, we will set the radicand greater than or equal to 0. So that is automatically going to give us a nonlinear inequality, or a quadratic inequality in this case. So when we have a nonlinear inequality, that's when we have to do that test chart stuff. Okay. So we're going to go back to those steps that we just went over a moment ago. The first thing we do is replace the inequality with an equal sign. So I am going to replace the inequality with an equal sign, solve the equation, use a number line. Then I can solve this either by factoring or complete the square, or quadratic formula. Whichever you are most comfortable with and can do without making a mistake. I prefer factoring. So, oh, that can't work. That has to go here. So 3x, x. So I have to multiply to get positive 2. So both of my values have to be negative in here. So if I do 3x times negative 1, that's negative 3. X times negative 2, negative 2. Okay, got it. Then we set each of these equal to 0. So 3x equals 2. So x equals 2/3 is one of my values. And x minus 1 equals 0. So x equals 1. So I take these two values and I put them on a number line. And since my original inequality up here was greater than or equal to, those values are going to have closed circles. So I have 2/3 here and 1 here. Then I usually go ahead and label my intervals. So this interval goes from negative infinity to 2/3. This one goes from 2/3 to 1, and then 1 to infinity. And then I'm going to test a number in each interval. So let's see. I got to test a number that's between negative infinity and 2/3. I kind of like testing x equals 0 whenever I can. So I will substitute 0 into this original inequality. So 3 times 0 squared minus 5 times 0 plus 2 is greater than or equal to 0. So that results in 2 greater than or equal to 0. That is true. So this interval here is going to be part of my answer. Then I will test a number in the center here, something between 2/3 and 1. Well, 2/3 is 0.6 repeating, and 1 is, of course, 1. So I need to pick something between 0.6666666 and 1. So like 0.7, 0.8, 0.9. 8 is my favorite number, so I'll go with 0.8. So I'm going to have 3 times 0.8 squared minus 5 times 0.8 plus 2 is greater than or equal to 0. Oh gosh, I don't know what that number is. I know 5 times 0.8 is 4. So negative 4 plus 2 greater than or equal to 0. Looks like I'm going to have to figure that out. Let me grab a calculator. Well, 0.8 squared would be 0.64, but I don't know what that times 3 is. 1.92. So 1.92 minus 4 plus 2 is negative 0.08, and that is not greater than or equal to 0. So that is false. So this section is not part of our solution. And then I need to pick a number that is between 1 and infinity. So I'm just going to pick 10. So we got 3 times 10 squared minus 5 times 10 plus 2 is greater than or equal to 0. So that guy is 300 minus 50 plus 2 is greater than or equal to 0. That is going to be true. So I will shade that part of my number line up here. And now I have 2 types of answers already done. So here is my answer in on a number line. And then in interval notation, I have it written out here, negative infinity to 2/3 and 1 to infinity. So I just have to go negative infinity to 2/3 u 1 to infinity. And then set builder. So in set builder notation, that's the curly bracket x such that I have 2 intervals, so I'm going to have 2 inequalities. This interval here is all the x values that are smaller than or equal to 2/3. So x is less than or equal to 2/3, or that union symbol means or. This interval is all the x values that are bigger than or equal to 1. So or x is greater than or equal to 1. And those are the 3 types of answers you might be asked for. So just make sure that you're reading the blue words in my math lab and the instructions when you take a test.